We got it.
Great. Hello, I'm Lisa Lorenzin, Senior Director of Transformation Strategy with Zscaler, here with my colleague, Steve Kovac.
Hi guys, I'm Steve Kovac. I'm the Chief Compliance Officer at Zscaler.
And we're here to talk with you about secure digital transformation with Zscaler's Zero Trust Exchange and how we address the scenarios and the use cases identified by ATARC. So Zscaler, if you're not familiar with us, we are one of the foremost leaders in securing digital transformation. We have a secure cloud for both private sector and public sector use that allows users to safely connect to resources, both public and private, and gives organizations full visibility and control of those connections. We are one of the market leaders across various analyst reports. We've been a leader for Gartner for the past decade. We've innovative technologies and highly satisfied customers. And our Zero Trust platform allows you to extend the principles of Zero Trust, context-based, least privilege access with a seamless user experience across all varieties of connectivity, whether it's user to application or workload to workload, whether those users are on-premise or off, whether the applications are in the cloud or in a traditional data center. We have the trust of over a quarter of the Forbes Global 2000, as well as a wide range of public sector customers. And we're protecting against cyber threats across the entire cloud platform. So we are detecting and preventing over 7 billion security incidents and policy violations a day. And we're handling that across 165 billion daily transactions. And just for a little context, that's about 15 times the number of Google searches that Google handles in a day. The results are clear. We've seen some of the largest and most demanding companies in the world get faster user experience, better threat protection against infections and resulting compromises, and cost reductions across their global networks. So if we think about what's necessary for reducing cyber risk, we really see that there are a number of areas that we have to address here. And the first one is cut off the kill chain before it even starts. If we can protect a user while they are browsing the internet, if we can protect the data that is in software as a service applications, if we can ensure that even workload protection is applied, we can prevent the foothold that's gained to launch phishing attacks, ransomware, infect environments with botnets, et cetera. So let's say that that organization, unfortunately, has some insider threat or internal issues. Somebody brings in a system on premise or attaches it to the network over something like a VPN. So now you have the attacker inside the building, the principle of assume breach. We still want to cut them off at the knees, stop them from finding high value targets by segmenting both user to application traffic, as well as workload to workload communications, and even introducing things like honeypots and active defense. And then finally, we also want to ensure that any compromise that happens doesn't result in a breach or data loss. So not only do we protect the user going outbound, but we also protect the data to make sure that nothing good leaks out, as well as protecting that nothing bad sneaks in. So this could apply across things like CASB for protecting data in a software as a service environment, data leak prevention to look for sensitive data, or even cloud security posture management to protect the configurations and the workloads in the cloud. Across this entire environment, we're leveraging artificial intelligence and machine learning to ensure that we can look for behavior patterns, see these zero-day exploits where there may not be a signature, but there may be a pattern of behavior that's unusual that can be detected with a heuristic. And this can all tie into various different risk scores, allowing for adaptive, responsive protection. So we can understand the overall risk and prioritize where we want to focus to minimize that risk. Zscaler's Zero Trust Exchange protects both traffic for users, leveraging our Zscaler internet access as well as our Zscaler private access. We also protect traffic for workloads with our Zscaler workload segmentation. So these are the technologies we're going to focus on today in terms of Zero Trust protection. We underlie this with our Zscaler digital experience, which allows you to get a full visual into the entire path that a user is taking to access a resource to understand performance, hotspots, congestion, what could be causing issues for your users. And then across the compliance spectrum, we have the ability to do CSPM and CIEM to protect against misconfigurations and accidental potential exposures in the cloud. This allows us to provide cyber threat protection in 3 areas, really. The first biggest solution area is a modern workplace enablement. And the pandemic has changed things in so many ways. First, 18 months ago, we all went home. Now we're teleworking. We have to find a way to give users access to critical resources. This drove an acceleration of existing trends, moving applications to the cloud, moving users off premise. As vaccination spreads, we get better treatments and better protective protocols. We're now finding that it is safe to come back to the office, to see our colleagues again. And we're realizing that we want to extend that visibility and granular control to our on-premise users, as well as remote workers. And no matter where that user sits, we want to ensure a great user experience. And then finally, we're focused on security transformation across this new modern workplace. So we have to protect from cyber threats. The incidence of ransomware has skyrocketed over the last 2 years as bad actors are taking advantage of some of the disruptions of the pandemic. And at the same time, we've also seen more threat actors in terms of APT or nation state sponsored attacks. So we need to protect against those threats and protect the data itself. This is all taking place in the context of network modernization. There have been more and more pushes to move away from heavy, expensive, dedicated networks that may be static, requiring traffic to be brought back to a single ingress point to access internal resources, or a single data center to go out through an outbound security stack. Now we're seeing a move for direct to cloud and local internet breakout. And we're also seeing the requirement to protect communication between cloud environments. So there's a wide range of factors at work here. And the Zero Trust Exchange allows us to increase productivity, minimize risk, and reduce the expense, the cost, and the complexity of a zero trust approach to protecting these resources. When we think about zero trust, there's no point solution. There's no silver bullet. It's always an ecosystem. And we've seen that in several of the other ATARC zero trust demonstrations. Zscaler believes very strongly in the power of integrations and API-based communication, whether that is protecting traffic in software as a service environments, infrastructure, or platform as a service, where you want the benefits of cloud resilience and flexibility, but you don't want to publicly expose those applications, or applications that are still in the data center, maybe migrating someday, maybe never leaving. You know, there's big iron that may just never get moved to the cloud. So we work with the solutions you've already deployed. We leverage these API integrations in a variety of ways to ensure that you can leverage your existing investment, whether that's in identity and access management across leading ICAM platforms, whether it is in your security operations environment with existing SIM or threat intelligence and threat sharing, and even down to the endpoint level for both management and deployment, as well as endpoint protection, the ability to consume context and risk scores from some of our EDR partners. And again, with that network transformation going on, we partner with some of the leading SD-WAN vendors to ensure that as your network modernizes, your security solutions are consistent across these changes. So we can really reduce both cost and operational complexity as you start to move through the phases of a zero trust transformation. We're able to do this based on our proven ability to scale. Zscaler, the term itself, means the zenith of scalability. And our cloud native architecture makes it possible for us to achieve that massive scale. We've got over 40 million concurrent active users a day, generating those 160 billion transactions a day. And the security updates are also unique in that we're pushing out over 200,000 individual updates in any given day. So we've got a wide range of users on this commercial environment. And in the federal environment, we have the certifications and authorizations necessary to extend these protections to our public sector customers as well. And at this point, Steve's going to tell you a little bit more about that. So Steve, want to tell us about some of these compliance considerations?
Sure, happy to do so. I would point out on that map, obviously GovCloud doesn't run in all those locations across the globe. Our current zero trust platform, the Zscaler private access, is at the high baseline, JAB high baseline today. And so obviously at that JAB high baseline, compute must remain in the US. So all that is done today in AWS and AWS GovCloud. So that want to make sure everyone understands we're not saying that we're at 150 data centers across the board with our high baseline.
That's a fantastic point, but I do want to extend that thought to say, in addition to the Zscaler hosted cloud infrastructure, we also have the option to run a private service edge that extends our cloud infrastructure into any US soil or US controlled environment across the globe.
Yep, great, exactly right. And we are doing that today. We have our platform extended across the globe and into customer data centers, as long as it is considered sovereign soil, U.S. sovereign soil. And as well, we are, you'll see real soon, we're relaunching our moderate platform. We're going to do a ZPA, it's already built. We're going through certification now on our ZPA moderate platform, which we will roll out to all those 150 locations when the timing is right. But let's get into compliance just for a minute, where we are today. So if you look at the slide in front of us, you see our Zscaler Internet Access, which is our VTIC, is at FedRAMP moderate today authorized. FCC is our sponsor. It is also, ZIA is also in is FedRAMP as of Friday, it's FedRAMP ready now, as you can see on the marketplace, for the high baseline with JAB. So both of our platforms will be JAB high. And actually we merge it as one under the Zero Trust Exchange, but it will be JAB high, as well as the one Lisa's we'll continue to talk about today, which is ZPA, which is currently at JAB high. 2 weeks ago, we received our IL5 PTO from DISA on ZPA, our Zero Trust platform, and we are sponsored on our VTIC platform as well to go to IL5. I also threw in the upper right-hand corner, I threw in that flag. Most people don't know what it is, but I'll talk to it just for a second. It is the 5 Alliances flag, the 5 Alliances flag. So we are also certified the same way in all of the 5 Alliances countries, in all English-speaking nations, the 5 Alliance countries. So, very robust. We're top of the line when it comes to security. Literally by the end of this year, you'll see high, IL5. And I think that's our goal. Next
Wonderful,
slide,
thank you. Let's also talk about how we relate to the TIC 3.0 platform.
Yeah, so a lot of you probably heard me, if you know me, which I know many of you on the call have heard me stomp my foot all around TIC 3.0 since 2017. I've been banging my head on the TIC 3, getting TIC updated. Obviously, a lot of work went into that, working with CISA use cases, the trials, all the things that we did. And in September 2019, OMB did, modify the TIC 3.0 initiative and rescinded the current TIC 2.2 policy to replace it with TIC 3.0. TIC 3.0 is important, right? It enables flexibility. It enables us to go directly to the internet without having to be backhauled through, laborious old MTIPS environments or, agency-owned TICs. So DISA released their guidance in December 2019. By that time in 2019, we were already starting. We're engaged in several of the initial use cases. Of the initial 5, we were heavily embedded in 4 of the initial 5, and the 5th one is now a customer of ours as well. And we went on to do many, many more what they call the use cases, test cases, trials. All of our trials ended up being documented as a success. And then during the summer months when COVID hit, DISA issued this interim policy on remote office mobile user that allowed us to allow agencies, publicly like CDC, that have come out and said, we need to get our people working at home. We can't backhaul to the office. We can't backhaul them to a data center. They just need to be able to go direct to the application. So CISA did pass the interim telework, which was heavily utilized, and our platform at that point, grew substantially. I think Lisa talked about the size of the number of transactions we do every day, but in that world, during the COVID time, we surpassed over 100 agency accounts on our platform, and it's grown substantially since that time. So that was a very big success, and that obviously became adopted as a full policy a few months down the road. So, what we do, Zscaler is really focused on this. This is really how we kind of made our name coming in, is really enabling cloud enablement, cloud adoption, modernization, and the TIC 3.0 use cases really drove that. Next slide, Lisa. Mm-hmm. Just for you all that don't know the use cases, I just throw them up here just for a quick walkthrough. Obviously, the traditional use case for TIC didn't go away, but it did offer another flavor, which you can go either. You can obviously continue to use MTIPs or agency TIC. That's not going to go away, but it also offered the ability to, allow campuses and agencies to go direct to a security cloud as a service that had met what they call the TIC 3.0 overlay and had gone through, has proven that they meet all the rigor of CISA. There is no such thing as a certified TIC 3.0 provider. There are TIC 3.0 providers that it's the agency's decision to select a provider other than current MTIPs or TIC, but they're encouraged to use the overlay and also encouraged to look at the use cases and who was involved in that. And obviously, our overlay is posted on our website. Please check it out if you like under zscaler.com/compliance. It's there for you to review. So this is the traditional one. Lisa, can you go to the next slide? Right after that, they released Branch Office, which was the original, which was allowing now not only just to go from your data center, but now for your branch offices to go direct to the internet. So whether it was the agency came back to the data center and the data center went direct to the internet to get it, or it was just the branch office went direct to the internet. The branch office was the first time, this was the second one to come out. And it really, again, enabled more cloud adoption because, again, you're not backhauling everything back someplace. You're not trying to, pull everybody back to your data center off to an MTIPS. Even the branch offices could go direct to the internet. And this was really when we started seeing, some really creative solutions here. And you started seeing, people that have multiple branch offices. And I can think of many of the agencies, certain agencies that have, 50, 60 offices around the United States. They could now go direct to the internet. So all that big backhaul network that they were using to backhaul internet back to their data center and then send out to the data center, that became obsolete, right? It became, it became back up and became, much smaller spend. And this allowed, multiple agencies with multiple offices to go direct to the internet and get a much better user experience, not only just going to the internet, but also to their SaaS providers and going direct to the application, right? And that's the important thing, right? The whole concept of Zero Trust is putting that user direct to the application without putting them on the network. And this is what this use case really talked to, and this is what Zscaler delivers on every single day. Last one is telework. It just got rid. It's called remote user. I should have changed the slide, but it was the same thing. Telework, remote user. This was really the one from the summer that got put into final form, which allows traffic to go directly from a teleworker, whether they're sitting at home, sitting at a Starbucks, sitting wherever they want to sit. That allows that person to go directly to a security as a service provider, then directly to the web and then to their application. And without having to backhaul back to an agency DC. Now, in this case, they show the one going back to an agency DC because there are still some agencies that say, yeah, I still want them to hop through my agency, but I'm not gonna, but only from there, I'll just send them straight to the cloud from there. We obviously recommend the second one, which is telework directly to the cloud. It's a much, much easier, much more trimline. It's the Zero Trust approach. It's what we've been talking about on these calls for the last 6-8 months that this call has been going on. Next one, Lisa. I think this is a build out. Is it built out? So obviously, no worries. Obviously, when you talk about risk management framework, it's integral to what we do. I mean, most of you guys that know us know what we've put together in the last 5 years, actually 4 years. We've put together an expertise really focusing on many of the NIST controls, obviously the L5 controls, the DoD requirements around the STIG. And SRG, we on the commercial side, we have SOC, we have FISMA, we have we have SOC, we have SOC, FIPS, ISO, FISMA. Obviously being FedRAMP 800, 530. Wow, that's the first time I've ever done that before. Obviously with FedRAMP, we meet the NIST requirements, and also with recently we were finishing up our internal audit and finishing our 181 to get ready for CMMC. So we're obviously continuing to push the compliance barriers forward as far as we can push them. And Zscaler private access, we talked about this earlier, FedRAMP High, JAB approved over a year, multiple large agencies using this product today. And as I said, just got L5. And we talked about ZIA, internet access is obviously moderate, going to high now. And IO5 and is just waiting for a FedRAMP approval to kick that off. So, I'll sum up here by saying, when you look at Zscaler, we're cloud-based, right? We don't have any, we don't ever sell an appliance. We have the ability to extend into customer location, but we're extending our own infrastructure, our own managed stuff. So the client doesn't buy that, doesn't own it, doesn't manage it. It is a full cloud infrastructure. So, we're looking at everything today that NIST would put controls in that could be on DoD site or on an agency site. We live up to all those controls within our cloud. So full cloud delivery, but the way you justify the power of the cloud and the way you look at how does an agency know, if they don't have a box in their data center, how do you know what's behind the cloud, what's behind the covers of a cloud if you don't have the certifications? And that's really how we think of it. We feel that certifications tells the story of what you get behind the covers of our cloud. And the only way to tell that story is by being the highest level of certifications out there, which we have done, continue to do year over year, and will continue going forward.
Great, thanks, Steve. So I think that's a great overview of what we're doing and how we're positioning it to serve the needs of the federal government. Let's look under the hood now and see how we're doing it. So the Zscaler Zero Trust Exchange is a true secure access service edge, or SASE. We are security as a service in the cloud. The intelligence is in the cloud service, which allows us to be thin at the edge, both on the end user side as well as on the application side. This means that regardless of whether a user is coming from a branch, a headquarters environment, whether there's traffic from a data center environment, whether this is a traditional MPLS-based network or has moved towards SD-WAN, we have a consistent policy and control. And then as we start to look at the remote user use case, I could be on premise. I hope to get back to the Zscaler offices soon. I could be in my home office. I may even be traveling again soon. And again, my experience should be consistent and seamless, regardless of where I'm coming from. And the visibility and control that an administrator has for my traffic should as well. We tie into existing identity and access management. So you can leverage your own multi-factor authentication, your own intelligent context in partners like Azure AD or Okta or Ping or SailPoint or really any SAML IDP out there for identity and context. And we extend these protections both for outbound traffic that would normally in the traditional stack have to come back to a data center to go through an outbound security stack. Now Zscaler Internet Access allows us to apply the cyber threat protections, the access control, and the data protection inline via this cloud service. So we really can reduce and in some cases entirely eliminate the need for the stack of appliances that used to be handling everything from URL filtering, content filtering, antivirus, outbound firewall, DLP, inspection at scale, even sandboxing of potentially malicious traffic. And then on the other side of the house, when you have private applications, internal applications, but they may be running on a public cloud provider, they may be in hybrid cloud, they may be still in a data center, they may be in a headquarters environment, even a heavy branch, regardless of where those apps sit, we can leverage our cloud solution to deliver zero trust access for users that are remote, users that are on premise. We do this by connecting a user to an application, not by connecting an endpoint to the network. So that helps us eliminate some of the risk that is incurred leveraging a traditional virtual private network, where you're really extending your network to that end user with all of the risk that that entails. We do dynamic discovery of applications and dynamic path selection to ensure the optimum performance and full visibility. And we can do this across a wide range of applications, from modern web apps to terminal services to fat client applications like a file share, complex apps like SAP, data center apps like a mainframe connection. So again, the ability to reduce and eliminate a stack of appliances, but this time that traditional inbound stack of a VPN gateway that's got to be clustered and load balanced, and it's in a DMZ, and you've got global server load balancing across multiple sites, and you've got denial of service protection. All of those functions move to the Zscaler cloud for centralization, distributed access, and full control. So we're going to start.
Can I add one question there? And I think, guys, really important to understand when you look at what Lisa just put up here, and I love the two X's on the screen where the appliance boxes go away. The key thing is we do all this, and it's all done in the cloud. So speed to market, speed to turn it up, I think of customers that have turned up, sites in Alaska in 2 days. We've turned up confidential sites around the globe in under 30 days. We have customers that have turned up, 40,000 users on this in a week, right? I mean, there's nothing to ship. It is, it's all virtual, it's all in the cloud. And because we're recognized as a TIC 3.0 provider, and we got the PTO, the PATO and DoD, that's already approved. So you don't have to go through a laborious process of, I got to get this one-off approved through my ATO. No, you've already got the authorities to do that. So it allows you to be nimble, quick, flexible, and deliver this at your pace, really at your pace.
Absolutely. And just to tell a quick story on that, as you can imagine, the beginning of the pandemic was a real shift for us. So in 2018 and 2019, traffic on our global ZPA platform, for example, we were growing about 4x every 12 months. So we were quadrupling every year in 2018, 2019. That's respectable. In 4 weeks at the beginning of 2020, between March and April, in 4 weeks, we grew 12x on ZPA. And that was terrifying, frankly, because we had a customer in particular who had, I think, 250,000 users on Zscaler internet access with their outbound traffic protected, but only about 40,000 users on private access. And they were still in the process of migrating off their VPN. They found that they could not scale their VPN to 100% remote work, and they moved the other 200,000 users over in a period of just a few weeks. What we learned was our solution does have the agility and the resilience to accommodate that traffic. We learned a lot about traffic distribution. Our dispatch got better. Our infrastructure got more distributed. There were probably some ops guys working around the clock for a while there. But fundamentally, a cloud-native multi-tenant zero trust solution means the ability to expand in response to any need. So breaking this down into Zscaler internet access and Zscaler private access, I'm going to start to tie this back to the ATARC scenarios as well. So if you look at the zero trust scenarios that ATARC identified, the first 4 are roughly user to application, and the next 4 are roughly application to application, a system talking to a system. So this initial portion, the user to app focused ZIA and ZPA, will start to talk about how we meet the scenarios that were outlined by ATARC and what makes Zscaler different in how we deliver that. So if you think about a legacy security stack, or even a pseudo cloud architecture where you have static components that used to be a physical box in a data center, now it's a VM running on a cloud provider. Our elastic cloud architecture is built from the ground up. So in a security stack that's built with static components, packets are service chained across, didn't mean to do that yet. Packets are service chained across one component to the next. So at each hop along the way, those components have to take the packet off the wire, load the policy, execute the policy, log information, and then put the packet back on the wire and send it to the next component. So this process adds a lot of latency at each hop, and that adds up to create a really poor end user experience. It doesn't scale from a performance perspective because of this service chaining, and it also doesn't scale well from a cost perspective because you're continually refreshing the stack every 3 to 5 years to keep up with growing bandwidth demands or new feature capabilities. Operationally, it's challenging too, because the administrative interfaces of all of these appliances, probably from different vendors, they vary. Getting policy consistent across them is difficult. You're getting logs from a bunch of different appliances, and your backend SIM and reporting tools have to correlate all this data to make any sense of it. So the people in your SOC are really spending most of their time just trying to troubleshoot, pinpoint configuration problems, and they can't focus on the security events that should be really taking up their attention. You also have to patch and maintain all of these appliances based on the various patch intervals of the different vendors. And if you're using this in a network segmentation context, policy may be tied to a user's VLAN or a VRF. So again, it's very static and can be very brittle. The Zscaler elastic cloud architecture is extremely different. We start by separating control, enforcement, and management plane so that they each grow independent of each other as capacity demands. So as a consumer of this service, you never have to worry about buying a bigger box as your bandwidth needs grow, because it's all transparent to you in the software as a service model. All of the patches are taken care of behind the scenes by Zscaler, So the SOC can really focus on security and not configuration management and operational issues. And because it's a cloud service, policy is always consistent across every node in the system. So failovers are automatic and clean. Instead of getting logs from a bunch of devices that you have to correlate together, Zscaler provides a data-rich transaction record. So for this outbound traffic, we have over 90 attributes. We can capture who was trying to access what cloud resource and when, which policy allowed or blocked the transaction, what was observed even in the payload, because these days, 75% of advanced threats are sent via TLS encrypted channels. So not only do you have to deal with all this traffic, you have to break it open, look under the covers, and make sure that you can do that without adding delay to the end user. So this is really the value of an elastic cloud service that grows automatically to meet your growing bandwidth demands and processes this traffic without degrading end user experience. New capabilities and features can be added just by subscription. So it's not like you have to physically roll trucks or upgrade hardware. We'll see a lot of this in the demo to see how that applies. Another big advantage is the single scan multi-access process. Instead of having the latency, inefficiency, and performance challenges of service chaining, we operate a single scan multi-action solution that allows us to pull a transaction into memory just once and then apply all of the security analysis engines while that transaction is in memory. So we remove the redundancy and latency associated with the service chaining. And we can do this because instead of being a bunch of point solutions from a variety of vendors, our cloud native security OS has been developed over the past decade in-house. We even rewrote the TCP/IP stack, pulled it into user space to make the solution truly multi-tenant, and also to run about 100 times faster than a traditional TCP/IP stack on a Linux box. Our SSMA approach enables us to be roughly 25 to 50 times faster than the legacy approach, depending on what types of traffic you're handling, what services you're applying. And when we're applying these services, all of them get applied simultaneously at all times. So it's not like you're adding a service and you have to think about how much you're going to degrade the performance when you, for example, turn an IPS from inspecting part of the traffic to inspecting all the traffic, or you turn on DLP for a particular flow. On the other side of the house, Zscaler, excuse me, I need to check here because there's supposed to be a demo in here and it didn't launch. So let me just launch that demo real quick. So when we think about how this applies to the ATARC scenarios, the scenario that the Zscaler internet access solution applies to most is scenario 2, where we've got an agency employee working from a satellite office and government furnished equipment, and they're accessing internet sites. So these sites might vary between job-related research or personal use that's acceptable per the agency policy, but we need to protect that user from malicious external forces, and we also need to ensure that they're only following the limited personal use policy. So with Zscaler Internet Access, we're leveraging our Zscaler client connector to provide protection for this outbound traffic. And the user authenticates using your identity and access management. You can leverage any kind of multi-factor authentication. And once that service is enabled, it's going to protect all of their outbound traffic. So as users are browsing the web, you can go and see that they're passing through the Zscaler cloud. You can identify where they're coming from. So the user has the ability to verify their own protection, even provide information for troubleshooting if needed. So as they access authorized sites, you can see that this traffic is not interdicted. You can even bypass personal sites to ensure that there's no question of whether that's being intercepted. But if they're trying to visit sites that are unauthorized, such as any kind of gambling or perhaps less savory, they will get a warning, they'll get interdicted, the traffic won't go through. And again, we didn't have time to demonstrate every single feature, but they could have the ability to have traffic protected against malicious sites detected or sandboxed and quarantined if there was a download that they were trying to do that was suspicious. And as we move over to the administrator side of the house, you get a rich set of visibility across a variety of information. So you can see across your enterprise the top URLs visited. You can drill down into individual users. You can look at the policies that you can set for those users. So you have the ability to set policy that would allow you to protect user traffic that is going to sites that you need to ensure aren't dangerous. You can block traffic to sites that are not approved under your existing policies. And you can even determine when you're allowing traffic, are you doing any additional protection for that traffic? So the URL protection, the cloud app protection can extend beyond just 80 and 443 traffic, even to other ports and protocols. As we start to look at the logs that are available, you can get some rich insights into who is doing what in your environment. So you have the ability to drill down into specific details and different views for different types of traffic. And you can look at a particular user and see exactly who is going where, figure out what types of traffic they were accessing. So this could be making sure that an individual user is protected, or it could be if you feel that you're at risk of an insider threat, you could be looking more closely at their traffic to understand what they've been accessing. We talked about the rich data in the logs. So you can drill down into these logs, you can set different timeframes, you can stream all of this to a backend SIEM or threat sharing environment. And as you start to drill down into these logs, you can really get a sense of how much information is available in these environments. So you can look at a variety of different views and filters to identify the specific traffic that you're interested in exploring. And then you can even look through further to see how they connected to a resource, when they were blocked from accessing that resource, a ton of information about what services were applied, where they were coming from, what category the URL exists in. So this is that variety of different rich attributes that go into this metadata. You can report on this, you can use this to provide historical trending, you can alert on particular behavior patterns that you want to watch out for. So this helps not only with the specific scenario 2 with regard to protecting an employee going outbound, but it also helps with the scenarios at the end, 10, 11, and 12, where you're looking at how do you do performance and troubleshooting. And ATARC also identified a variety of use cases, whether that user is at a headquarters with reliable connectivity, maybe a branch or a satellite office with unreliable connectivity, or even a remote user. And the point I'd like to make here is that these solutions apply consistently and seamlessly across all of these different environments and use cases. Whether I'm sitting in an office, whether I'm at home, whether I'm in a Starbucks, whether I'm out working with another agency or another customer, the user experience is consistent, the protection is consistent, the visibility and control are consistent. So as we go along, and that talks to one of the questions in the chat, do we extend software as a service to remote data locations? Do the security standards apply to the remote data site? And I would say that yes, the user experience is consistent and the protection is consistent, regardless of whether the data is in the cloud, whether the data is in software as a service, or whether the user is going to an external. For the question about how Zscaler logs integrate with an agency's SOC logs, we have the ability to stream all of that rich metadata via syslog. So you can stream that as a syslog format, a standard format. It can be encrypted syslog. You can stream it to any log receiver. So you could feed it to a SIM, you could integrate it with Einstein or Claw. I'm gonna keep going here. So as we start to think about the other side of the house, we have Zscaler Private Access. And Zscaler Private Access really grew from our original customers on ZIA. After about 5 years, they started to come to us and say, we have users who are complaining that it's actually easier to get to SaaS apps than it is to get to apps in the data center. And then, as we move to private apps to the cloud. So they wanted the same flexibility and level of visibility and control for users connecting to internal resources that they already had for that external traffic. So this is where we started to look at how we deliver that, but you run into a few problems. When you have a virtual private network, connecting a remote endpoint to the network increases risk. And you have that open inbound listener that presents an external attack surface. You connect the user to the network, and then there's an internal attack surface as well. Generally, a VPN is a single ingress point, so you're backhauling the user around internally. And this is where Zscaler Private Access is really designed to address all of those issues. So how it works under the hood, first of all, we have that same separation of control plane, data plane, and management plane for config and logging. So the control plane is already established between the various components. You have the intelligence in the cloud itself, and this could either be the public service edges in Zscaler infrastructure or the private service edges on your premise. And we extend that to application environments by way of these app connectors that have outbound only connections to the cloud. So all these control plane connections are TLS encrypted, mutually authenticated, certificate pinned. The app connectors are lightweight virtual instances that can run in any backend environment, and they're cattle, not pets. You load a generic instance, put a provisioning key with a cryptographic identity, it enrolls to the cloud, and all of the control and updates are done by the cloud itself. So once we have that infrastructure in place, when a user tries to connect for the first time, they authenticate to your existing SAML identity provider. They get a SAML assertion, or we can do dynamic provisioning with SCIM. And now we have context for the user. We combine that with context for the device. And when they attempt to access a resource, the Zscaler solution uses that context to apply policy and identify, are they authorized to access the resource? And if so, apply a dynamic path selection algorithm to determine the best path to that resource. Once that best path is determined, the application environment starts the data plane connection with an outbound dedicated dynamic connection to the service edge. And then the user has a corresponding outbound data plane connection. So you can think of this as a little bit like MPLS in that it's a label switched network, but the transport is these TLS tunnels and the label is the microtunnel IDs tying these tunnels together. And it's micro-segmented, so only authorized traffic can transit the tunnel. We'll see that in the demo in a minute. We can establish these tunnels simultaneously to applications in various environments, whether it's multiple cloud providers or even maybe through a private service edge to an internal resource, still leveraging the public service edge to get to external resources. So there's a variety of topologies, and again, dynamic, provisioned, transparent to the user. So it means we've eliminated the inbound listener with these outbound only connections. We've eliminated the potential for lateral movement when you move to granular policies, but you do have the option to start in a connectivity mode because very few organizations can write all their policies up front. We've eliminated potential credential exposure that we've seen in a lot of these DHS and CISA alerts about compromised VPN gateways being used to compromise user credentials that are then used to penetrate deeper into the network. We've eliminated the risk of those unpatched gateways that any idiot can find by running Showdown, because we have only these outbound connections, so you can't scan for us, and the connectors are always kept up to date by the cloud anyway. This also helps us eliminate single points of failure because we can route through any element of the cloud to deliver traffic to the backend resource, and we've eliminated the backhaul and hairpinning that is generally imposed by a single ingress point. So we're able to grant conditional access based on the user and the device. If you're familiar with the DoD's zero trust reference architecture, they have multiple zero trust pillars, and we support the identification pillar and some of the device information as well by integrating with any SAML 2.0 identity provider. We have SCIM for auto provisioning, and we can enforce comply to connect using not only the machine learning and adaptive risk, but also multiple posture checks that can be run directly against the endpoint and API and platform integrations with things like EDR. So one example would be, if you want to verify that an end device is compliant, we would look at things like authenticating the user and then gathering perhaps a C2C score from an existing endpoint EDR solution, combining that with a posture check on the client connector, and then sharing that score with the cloud so we can decide whether or not to grant or block access based on that score. So when we go back to the ATARC scenarios, another one of the scenarios was a remote employee, but connecting on a personally owned device. And they might be connecting applications in the cloud. They can access as a standard user. Their physical location might change. So we may not be able to trust that they're coming from a reliable location. And we know we can't trust the device. And Zscaler enables us to carry that user in through a BYOD device by connecting them in through a browser-based access. So no agent is required. This application could be in the cloud or it could be in a data center. We capture that traffic and redirect the user to the Zscaler cloud. And then the user authenticates against the SAML identity provider for their organization. And this could, again, leverage your existing MFA. You could have multiple identity providers for different purposes. So one IDP for contractors, a different IDP for employees. You could even tie in a third-party IDP directly. You can give the user a portal with access to all of the resources they're permitted to access. And then when they actually access a resource, we can send that traffic through cloud browser isolation. And this ensures that the administrator has control of where the data from that application lands. So instead of connecting the end user device directly to the resource, we're actually connecting to an isolated browser instance in the Zscaler cloud and just rendering a stream of HTML5 back. So it's almost like the user's playing a video game. You can interact with the application, but the data is never cached. The administrator can control whether downloading or copy paste is permitted, et cetera. And the way that we capture this traffic is we use a DNS redirect to ensure that when a user requests a protected host, that request is CNAMEd over to the Zscaler cloud. So when you configure your ZPA environment, it gives you that terrible GUID.zpaapp.net. And all you have to do is plug that into your external DNS as a CNAME. The redirect carries the traffic to ZPA. ZPA identifies the policies that require the user to go through browser isolation, and we can enable that user on a personal device. You get full visibility and control of this traffic. So you can go in and see either an application-centric view or a user-centric view. And you can scroll down, find the user themselves, and identify exactly who's connecting, who you want to look into. Somebody please go on mute.
Kirsten, can you mute him, please?
Awesome, thank you.
Yes, sorry about that.
And then in the metadata, again, we get a rich set of metadata showing some standard things you'd get from any remote connection, you know, where they came from, total bandwidth, total duration. You can see start and stop time. All this goes into your SIM as well via syslog. You can see the policy that permitted the end user, so you can identify exactly why they were allowed or denied access. You can see who is connecting, and you can even get direct information about the end user, such as the location that they're coming from. We collect their external IP and geolocate that. You can also see a rich set of information about the user themselves. So you can see the context. For example, we can see here that the user failed a posture verification. So we know they're on BYOD. But we can go into the SAML attributes and see that this user is an employee, and that's why they were allowed to access that resource. So we can really go through and get a rich set of metadata about the end user and the request and the context that was used to allow the request. We see how they come to the resource through the Zscaler cloud, and we have the ability to trace that path, get a little information about how long it took to set up the connection, and then exactly what application. And this is true not only for web-based applications, but also for additional context like things like RDP or file shares where you would be connecting to a fat client application. So this applies for that BYOD user coming to resources, whether they're in the data center or in the cloud. The next step would be, let's talk about a contractor who's coming in. And this would apply to some of the other scenarios, like the user scenarios 3 and 4. So in this case, we've got a contractor, and that contractor is not an employee. So they're going to log into their own home IDP, or they're going to log into a contractor IDP. Once they get connected, you're going to see that unlike the employee who is going out to the internet and had both internet and ZPA, ZIA and ZPA, this user is only protected with private access. As a contractor connecting into this environment, they would be protected by whatever outbound protection their own organization had. So again, we have the ability to do things like access web applications. And in this case, we're able to determine that this is an authorized contractor on a company device. So that user is allowed to go to this resource. You can see that they weren't redirected to the IDP because they'd already logged in. And if we do an NS lookup here, we'll see a very different result, because instead of getting that DNS redirect, what we'll see is a synthetic IP address that's generated locally on the end user's device. So the end user still doesn't see any of the backend IP addresses, can't tell where the app is hosted, looks the same whether it's in the data center or the cloud. but they have the ability to access these resources and connect to the backend applications, just as if they were sitting on the same network as the resource. And this again could be web apps, et cetera. You can give the responsiveness and the dynamic performance that a user expects because we're building these dynamic TLS connections. So let's say now that we have different classes of contractors and they may need to access different things. So this user decides she needs to get to a file and she launches the file server, but she doesn't have access to do it. So she's going to get a warning that she's not actually allowed to access the resource. You can either choose to pop up a message and communicate with the user, or you can just come back as if the application doesn't even exist. So it's really up to the administrator. Do you want to expose that the app exists, or do you want to just not even give visibility that it's in the backend? And again, we can go in and see the rich metadata that's available for this user's access. So we go find this user and things are going to look a little bit different from our BYOD employee. So when we start to look at the metadata for this user, and again, you can filter on user, you can filter on applications, you can look for specific traffic. But we'll see here, again, you've got all the information about where she's connecting from, how she's connecting, who she is, what policy permitted the traffic. And we can even drill a little deeper into that access policy and see some of the elements of context that go in. So she's only allowed to access one resource. She's given access to that resource based on her SAML attributes. And we're requiring that she be on a company device and that be validated for her to access that resource. So you can see all that reflected in the metadata that's available in the logs. And again, this can be streamed to a SIM. So you can report on it, you can filter on it, you can validate that only authorized users are accessing particular resources. This is particularly helpful in an audit environment where you have to be able to demonstrate that, yes, this access was verified, that it came from an authorized device, and she was only going to the specific resources that she was allowed to connect to. There may also be somebody who wants to know why she was denied access to a particular resource. So maybe she calls her buddy and says, hey, I couldn't get into that server. Somebody at the help desk looks into it and sees this was blocked by policy. So she is not permitted to access that resource. She's going to need to reach out to somebody who has the right credentials to do so. So now we're going to flip over, and this is, obviously a demo environment. Instead of having a different PC, we're just going to log in as a new user. So now we're going to log in as another contractor, but this contractor maybe has a little more visibility into the backend environment, a little more rights based on their role or the individual, their department, et cetera. So again, we're going to see authenticating. Once ZPA is up, it's just going to run in the background and they don't have to interact with it unless you've set a requirement for reauthentication at a particular time. So now this user has some of the same access privileges. So they can go to various different resources in terms of what they need to do their job. This person might be, for example, a QA engineer, but he has access to these same different resources through ZPA. And you're going to see here that one of the advantages is we don't have to be using a internet resolvable DNS name. You can use completely internal DNS that's never exposed to the internet. And because the DNS resolution is handled within ZPA, he gets a synthetic IP address and he's able to access his resources. So he's going to go check on that server that his coworker asked him to check on. And he actually can log into the file share. In normal cases, this would just happen automatically because you'd have a drive mounted. But so he gets access to the file share and he can see that there's not a set of resources that they need. They can only see marketing things. So is this the wrong file server or is the data not there? He decides he's going to try to solve his own problem. So he's going to RDP into that server and poke around and see whether the information exists or whether it's not on that box. You'll notice he's connecting by a short name here. He's just connecting to server 01, but unfortunately, he doesn't have the access rights to RDP to it. So this shows you that authorization can be granular down to different services on the same backend host. He can mount the file share, but only a file share administrator is allowed to access the resource. And again, if we go in, we can drill in and see some of the rich metadata that could be used for investigation, for identifying who's allowed to connect to what resource. So we'll go through and see, again, the various elements of the metadata. You can feed that into the backend system. And in his case, he's got a policy that says he can get to not only the web apps that he needs, but also the file shares and different systems that he needs. So all of this can be defined in a single policy for a role or a group of users. So you don't have to have an extremely complex policy set with one-to-one mappings. You can combine different types of resources based on your user's group or role, or you can combine different users that can get access to a particular resource. And we can see again here, he's a contractor, he's on a company device, and he's accessing these internal systems. But when he tries to go to that system, he can only get to the things he's authorized for, and he's not allowed to connect to something like an RDP. So you would be able to see these policy blocks. And here we've created a explicit deny policy so that we can present that message to the user, give them some guidance. But if we didn't have an explicit deny policy, then we would be able to just not give the user any indication that the resource existed. So this allows you to really take internal applications dark if the end user is not authorized. And again, this applies whether you're in a headquarters, a satellite office with good connectivity, satellite office with bad connectivity, or even a remote user that's, again, on GFE and passes those requirements. And then finally, this guy calls his buddy and he says, okay, I know this file is somewhere, but I can't get to it. So can you help us find it? And now we have an administrator who has admin rights to that file server. So again, he's going to go through, and normally he would probably be authenticated already, but we're using a single environment to switch back and forth between users for the demo. So he gets connected. And in here, we can go in and see all the different things that he can connect to. And give that just a minute. So he's going to try to connect to various different resources. And you can see that he's allowed to connect to some of the same resources as the contractors, but he's actually got more capabilities. So if he goes to GitLab, for example, you're going to see that he doesn't have to connect to the browser isolation. He's just going to connect directly to the backend resource. And where Pamela, because she was on BYOD and remote, she was getting that redirect. He's on the client connector, so he's just getting this 100.64 connection. These synthetic IPs also, you'll notice that it was the same on Selena's system as it was on his. It's 164.1.1. Those IP addresses never leak off the end user's device, so they're really only used to connect to the end user. So when he connects in, the first thing he's going to do is he's going to do his homework and he's going to go check and see whether he can see the share. Maybe there's a permissions problem, but he goes in and he figures out that he has the same visibility to the resource that the contractor did. So he's going to RDP over to that system and try to figure out, is that file there? Is it just not shared properly? Or is this the wrong file server? So again, short names, the ability to connect directly in once you're authenticated. And in the interest of time, we're just going to show that you have an RDP connection. You can see that you're on the correct server, and that's basically it for that. So again, we have all of the visibility and control for where those users can go and the ability to send rich metadata to the backend system. So if we jump in and look at the administrator's access, again, we can go find the administrator, drill in and see exactly what he can get to. And I think in the interest of time, I'm going to skip forward on this since it looks like we're getting a little pressed for time. So this would again apply regardless of whether the user is in any of the different use cases in that environment. So we have
Lisa, real quick.
Go ahead.
Kirsten put a note. You got till 12:20.
Great, thank you. That helps a bunch. I appreciate it. So speaking of all of this rich metadata, we also leverage metadata from other environments. So as traffic passes through our security cloud, we can inspect and analyze that traffic and really just ensure that we can integrate threat intelligence and carry information from other threat feeds. And these come across a variety of different frameworks, whether that's our partnerships with other vendors, consumption of data from ISACs and certs, subscription to malware samples, et cetera, and even customers. So we have collaboration with our research group, Threat Labs, so that customers can report threat intelligence, and we ingest all of these threat feeds and combine them to provide comprehensive security. So that covers really the user to application side of the house. So there were a couple quick questions here. It's integrated with an IDP for authentication, and hopefully you could see in the policy where the authorization controls got implemented in the policy. And policy can be per user, it can be per, nobody really does per individual, that doesn't scale, but it can be per SAML attribute, like you could have a role, you could have a group, you could have a department that could be modified based on whether that user is on the IDP, I'm sorry, on BYOD, or on a company device from a third party, or on GFE. The policy is really what is all of the context that goes into my request, and then based on all of that context, what are you allowed to connect to? So it's a little more intelligent than an ACL, and it's focused on connecting a user to an application based on the whole range of context we can get, tied off the identity, but also the device, maybe location, maybe other things that we can get from threat sharing in the environment, like a CrowdStrike, ZTA score, et cetera. So switching gears, we're going to go to application, and these would be the ATARC scenarios 5 through 8, where you have an agency system in one environment talking to an agency system in another environment. And again, I'm not going to break this down into 5, 6, 7, 8, because to us, it doesn't matter. It's a cloud delivered overlay that allows us to apply this protection regardless of where the applications are hosted. But for us, now we're doing identity-based access control down to the software identity, down to the processor application between different servers. So we generate a process identity. We use that to identify which communication paths are valid in the environment. And the real challenge here is, if you think it's hard to write granular policies for which users can talk to what applications, imagine how challenging it would be to have to identify which processes need to talk to which other processes. So our workload segmentation solution leverages artificial intelligence and machine learning to automatically validate identity of processes and auto-segment a proposed policy for you. So you can see what's in the environment, what is already talking to other things, which network paths you want to shut down, and create a very simple set of rules. And this is necessary because in a firewall environment, once you get compromised, it's extremely hard to stop lateral movement. Most of the network paths in the environment are unnecessary, and they can be exploited to compromise targets and lead to data exfiltration. These pathways are an opportunity for an attacker to take advantage of, so we try to close them off with IP address-based rules. This servers in this subnet can talk to servers in this other subnet. Maybe we'll even get down to specific IP addresses and ports. But again, you've got an open port. An attacker could piggyback on these approved firewall rules, and the firewalls are often blind to what's going back and forth. The other challenge is if you're applying port and address-based rules, you really end up with a skyrocketing set of policies the more granular you try to get. So instead of applying these legacy network security controls, we're really looking at transforming towards an identity-based control, cryptographically fingerprinting all of the software communicating in the environment to identify it. And these fingerprints are high fidelity representations of what the application is, over 30 attributes. So we're identifying the software, not just the user. And analysts are really starting to recognize that identity-based microsegmentation allows you to move individual workloads to a default deny model using dynamic policy. So if we're verifying the identity of the software rather than the addresses, we can extend this down to the process level, and you can have one piece of software permitted and another piece of software blocked coming from the same server. So these identity policies are simpler. You've got the language, the application owner, you've got a single control plane for regardless of where the application sits, in the cloud, in the data center, in a virtual machine or a container. And there are no changes required to the application itself or to the network. So this lets you auto-segment the environment and get the right balance between specificity and operational overhead. You can safely group software into groups of clients and services and allow a single policy permitting that connection because you're validating the identity of every application. So we can prevent piggybacking attacks and block introduction of malware. In the demo environment, we've got a 4-node workload, and that includes a remote access client, that's run from an administrative system that connects to all of the other hosts. And then you've got a FAT client that connects to the web application server, a web application server itself, and that's connecting back to a database server. And again, since workload segmentation is hypervisor and network agnostic, doesn't matter where these hosts are located. In this case, some of them are in AWS and others are on-prem. So our zero trust protection strategy means that when policy is applied, default blocks are applied to the inbound and outbound directions of each host segment. So only explicitly approved applications can communicate. And this host segment model allows for easy scaling up or down of application tiers, because you can simply add a new host to an existing host segment and any existing policy is applied. So when we start to think about deployment, get a little more into the demo here. We can deploy these agents onto the network. And once the agent is deployed, it starts tracking every application on these hosts that makes a network connection. So you can see details of the host. You can allow administrators to view what's occurring in the network and to build a better understanding of what's occurring within the perimeter. So this gives us really rich visibility. Visibility is the first value provided by workload segmentation, and it's available within hours of deploying these workload segmentation agents. You can see different processes running. You can drill down into the application details itself. You can see the file name that launched or the process name that's running, whether it's containerized or not. You can even check things like a hash to ensure that it's the process you expect to be running under that file name. So you've got a lot of visibility here for the various different processes that are running on the various different servers. You can change around and look at different targets, so you can see particular hosts and get a visibility into different details, different segments, different applications running in different environments. And again, it's very easy to browse through this and understand exactly what's running on each component of the system. So once we've had a chance to look through all these applications, we can look and see also different views, like what policy might be applied here and what communication is happening between different systems. So here we see that there's communication between all of these different services. And right now we don't have any policy being applied to these connections. So this is a good point where we might want to start developing some of those policies. The first step to building a protection strategy is to create logical groupings of hosts called host segments. And in this case, what we're going to do is take that visibility of what processes are talking to what other processes, and we're going to create both a default deny policy to deny unapproved traffic, but then create a host segment that will be the foundation for where we do want to permit traffic. And there are multiple different ways to create a host segment. You can define that as a list of hosts, which is what we see here. But we also have the ability to create dynamic host segments that might automatically pull in hosts that might match a given criteria. So it could be a partial host name match. Maybe you have server 1 through 25, and you just want to have all of those automatically mapped to a dynamic host segment. And another option, especially if you've got a well characterized backend application environment, would be to ingest host segment mappings from something like a comma separated value list. So we can see the process here to create different host segments for the different components in the demo environment. And once we get these host segments created, we'll be able to start building and applying the policies to them. So again, this can be done manually. Very often it's going to be more effective to use one of the other tools that applies host segmentation, and that would be the dynamic host segment mappings, or even host segment mappings that you can pull in from the background information that you already have. So once we have those host segments, then the next step is to go through the automated workflows that exist that allow us to implement and maintain segmentation in this environment. And one of those tools is auto segmentation. So this workflow will automatically create a baseline policy set based on the knowledge of which applications have previously communicated into, inside of, or out of a host segment. So you can go through and apply protection across these inbound perimeter protections, the outbound protections, or internal communications. And you'll notice here that we're doing simulated blocks, because very rarely do you want to launch enforcement in the learning process. So we want to permit the traffic that we know is going to be authorized. We also want to ensure that we aren't blocking traffic for any particular user that may not necessarily be detected initially, or in the time frame. You've got environments where a workload may only run once a month or once a quarter. So you choose the time frame that you want to extend your discovery process, and then you create policies with simulated blocks to allow you to see what would have been blocked and to detect additional traffic. So now that we've got these segments generated, we have various policies that are created based on the existing traffic. And so you have this auto segmentation summary that will show you the policy that was built. And you have the ability to go in and adjust that policy as well. So I can drill in and I can see exactly which processes on a particular host are communicating, and what they may want to communicate with, what network they're coming from, particular IP addresses, et cetera. So there's a variety of different visibility that you can go through in here to understand how applications are communicating with each other, what policy will be applied to that traffic, and really takes away, again, a lot of the guesswork of going to an application owner, asking them, what are all the applications in your environment? What are the functions that those applications perform, and how do those applications communicate with each other? If you're lucky enough to be running applications in the cloud, you probably have better visibility into this because you're paying for those workloads. But especially for applications in a more traditional data center environment, this can be a real challenge to collect that information. So the next step here then is to really think about the information that you can see, monitoring that data. Oop. I would like to actually play you. Thank you. Here we go. So now when a host segment is configured to operate in a simulated block mode, the monitor view is going to show you deviations from the baseline. You can see that whether these are malicious connections or possibly new connections that are not yet included in the policy set. So here we're going to see the process of reviewing connection events, and then we can identify a connection that was simulated to be blocked, but we need to allow that connection. And there's a workflow to do that called auto resegmentation. The auto resegmentation will update your existing policy to enable this simulated block of permitted traffic. We'll take that permitted traffic and we'll actually ensure that it is correctly permitted in the environment. So once we do the auto resegment, again, we can step through and ensure that our high-level definitions are correct. We can see the changes that are going to be made in the environment. So you can see the assigned paths. You can see what you want to differ here in the auto resegmentation and verify the various different information that you want to look for in this interface. You can see the paths that are going to be changed when you do the auto resegmentation, verify that these are in fact the workflows that you desire to permit, and then again, resegment, and it will update those existing segments and create whatever new segments are needed. And so once we've gone through this process, it will allow us to turn those perimeter policies to a full enforcement. So once we've done the initial segmentation, looked at the monitoring and the events for what was simulated to be blocked, now we have the confidence that we can go from a simulated block to truly enforcing in this environment. And now we are truly protecting, and you can see we can set exceptions in here if there are still things that we need to protect against. You get one last chance to think about it before we apply our changes. So at this point, the environment is fully protected with this identity-based segmentation, and you've got the default deny perimeters applied on each host segment. Only explicitly permitted applications can communicate. And if an application tries to communicate that doesn't match the fingerprint of a known application, even that traffic will be blocked. So we can see this very quickly here, in that someone has tried to SSH from one system to another, and that may or may not be a malicious connection, but it's definitely not a connection that we want to permit. So we can go into the enforcement and see exactly the blocked traffic, see what it's trying to communicate to and from, and now you can go investigate. Is SSH a service that should be running in this environment? Probably not, or we would have known about it before, but we can see that we're protected against this because this traffic has been detected as not matching the policy and it's being prohibited. So this really allows us to move that problem space of lateral movement and exfiltration of data, the reaching of target hosts. We can cut that off again at the beginning of the kill chain because the traffic isn't allowed to communicate anywhere in the environment unless it's authorized. So this gives us visibility, zero trust enforcement, the ability to drastically reduce the number of security policies, and risk reduction, both directly and tangibly in terms of the more granular control, but also in, again, taking away a lot of the hard work of identifying and coordinating this policy setting and this discovery in the environment, so that administrators can really focus on the important work of understanding the exceptions. Across the entire Zero Trust Exchange, we've been around over a dozen years. We have thousands of customers around the world, and you can see how just some of our customers scale across different countries, across the number of locations protected, across the number of users protected. The monthly traffic in, for example, our largest single consumption of traffic would be M365. We are widely adopted in the defense industrial base as well as across federal and DoD customers. And this is just an example. We have more than this, but there's only so much room on the slide. We also partner, again, with a lot of organizations ranging from Microsoft, Okta, CrowdStrike, Carbon Black, that whole ecosystem that we saw at the beginning. And we've been recognized by some of these partners as, for example, Microsoft's ISV Partner of the Year in 2020, Zero Trust Champion in 2021. So our goal here is really to give you four things. We want to deliver higher user productivity. We want to ensure that users take the fastest path to a resource. We don't want to backhaul or hairpin them around. And we want to offer that seamless, transparent protection to these users. We want to mitigate and control risk. So eliminating external attack surface, minimizing internal attack surface, protect against sophisticated attacks, and ensure that the data, not only the traffic, but the data is protected. And we need to do that while reducing cost and complexity, because everybody's busy enough these days. We're all trying to do more with lower budget. We need to meet the requirements of the cybersecurity executive order. We need to bring our users back to the office and have the ability to give them a seamless experience across this new transition. So really the ability to consolidate, to eliminate point solutions, to reduce the complexity of the infrastructure environment, and to draw down the costs of some of these dedicated sort of legacy network models helps a lot. And all of this accelerates IT modernization. You've got the flexibility of deployment, and you can enable new use cases leveraging this TIC 3.0 approach, providing you the ability to really complete the mission, to empower your users, and to achieve whatever your outcomes are desired. So Chris Drumgoole was the CTO of GE at the time. He spoke at one of our Zenith Lives. And we all know the triangle of fast, secure, and cheap, and you pick two. And he really believed at the time, you know, he was speaking at one of our events and he said, it's one of those rare occasions where you don't have to choose and you can get all three. So Kovac, any final thoughts before we wrap up?
No, I appreciate it, Lisa. What I would say to everybody is that, obviously we're being 100% born and bred in the cloud. We're not going to have anything in the lab to see, but for sure, Lisa we have our demo available for people to use and try, and Lisa will make sure you all have that information, the demo, to check it out on your own. Everybody that's asked questions, great questions in the chat. Lisa and I will handle those after we let go and let everybody start. Thank you all for your time, and we really appreciate it, Lisa. Wonderful job, and thanks to ATARC.